it is solar that is the largest market, and we expect it to continue to be so. Here we're looking at annual capacity additions by energy source. We kind of zoom in on solar on the right-hand side. And 2025 will be a record year for renewable capacity growth with above 600.
Kind of related to the insulation oils, as oil is used as the heating dissipation fluid. Here, you need to make sure that the temperature stay under the normal conditions when the transformer is working normally. So here, directly at the factory, we'll connect the transformer.
And looking at kind of the top countries that has been importing transformers into Europe over the last 4 years, we can see that there are here both China and South Korea are now kind of on the top list. China is the number 5 largest exporter.
Hello, everybody, and welcome to Sinovoltaics webinar on power transformers. We have people joining this webinar from various parts of the world, so that's great, and warm welcome to everybody. My name is Rystad Energy. I'm media manager at Sinovoltaics, and today I will be moderating this timely and insightful webinar on power transformer supply chain. We are currently facing a global shortage of power transformers, and getting them now takes much longer, sometimes up to 3 years instead of just a few weeks. This is happening at the same time as our energy needs are growing, infrastructure is aging, and extreme weather events are becoming more common. In the US alone, there are over 80,000 different transformer types, which makes buying the right one even more challenging. So today, we'll talk about how you can deal with these issues by making smart sourcing decisions, forecasting prices, and building strong and flexible supply chain. And most importantly, we will look at how to make sure that your purchase contract works in your favor. Before I introduce today's speakers, I would like to briefly share some housekeeping rules. So 2 expert presentations will take around 45 minutes and will be followed by a questions and answer session. During the presentations, I encourage you to post any questions you might have in the chat box. You can find the chat box on the right-hand side of your screen. And then at the end of the presentations, I will address the questions to the respective expert. I would like to remind you that this webinar is being recorded and will be uploaded on Sinovoltaics YouTube channel. If you don't want to miss the newest content updates on YouTube, don't forget to subscribe our channel there. So now let me introduce our esteemed speakers. So today we have Edvard Christoffersen from Rystad Energy. Edvard is a senior supply chain analyst where he leads a research team dedicated to analyzing the grid equipment supply chain with a particular emphasis on capital equipment used across both fossil and low carbon energy sectors. His work integrates computational modeling, in-depth supplier research, and cost inflation analysis to provide strategic insights into the evolving energy landscape. Edvard holds a Master of Engineering in Material Science and Engineering from Imperial College London. And Rystad Energy is an independent energy consulting and business intelligence firm that provides global databases, strategic advisory services, and research products to energy companies, suppliers, investors, investment banks, organizations, and governments. And the next expert speaker joining us today is my colleague Arthur Clare, Director of Technology at Sinovoltaics. Operating out of Lausanne, Switzerland, Arthur supports independent power producers, IPPs, and engineering, procurement, and construction, EPC firms in deploying high-quality, reliable solar modules and BESS systems to comprehensive traceability and quality inspection services. He brings a strong understanding of diverse technologies and maintains deep knowledge of key market players across the industry. So now I'm going to quickly present today's agenda. So Edvard will kick off this session by providing a helicopter view on the renewable energy and transformer markets with a particular focus on grid infrastructure and its key components. He will then delve into the current dynamics of the transformer supply chain. We'll talk about trends in pricing and lead times as observed by Rystad Energy. Finally, he will explore how developers can effectively navigate procurement risks in today's challenging and rapidly evolving landscape. And Arthur then discuss supplier selection, key contract terms essential for managing risk in power transformer procurement, and will delve deeper into the factory acceptance testing. So now I hand over the virtual microphone to Edvard. Edvard, the floor is yours.
Thank you very much for the warm introduction, Rasa, and welcome everyone to the webinar. It's a very exciting time to be a supply chain analyst within the transformer market. And as was introduced, today we'll speak a bit about trying to quantify supply and demand and the trends that we are seeing in the market. Then going into a bit on how prices and lead times has evolved and how it impacts procurement. Today we'll focus mostly on medium to high voltage, so kind of on the power transformer side, relevant for collector and substation size transformers. And to highlight the importance of transformers and electricity in the energy sector, I will start a bit macro before we go into the details of the transformer markets specifically. So looking at global power demand and supply, we have seen that kind of in the last 3 decades since 1990, we have had a gradual increase in power demand at around 2.9% annual growth rate, driven mostly by strong economic growth in Asia. And going forward, we also expect a strong continued growth in power demand at a similar rate of around 2.7% annually over the next 25 years, so until 2050. And 2.7% over 25 years actually means that we're looking at nearly doubling today's power demand by 2050. Electricity is becoming a dominant primary energy carrier, and basically all energy consuming sectors will see some level of increased electrification going forward. And in EU and US, it's particularly industry with reshoring and decarbonization of industrial sector, in addition to electrification of road transport with EVs, and also growth in demand from data centers that will drive power demand going forward. And most of this demand will be covered by an increase in supply from solar and wind in particular to reach net zero targets. And by the end of this year, we actually expect that renewables will make up almost half of the installed power capacity for electricity globally, though it's nearly half in capacity, but because of a bit lower average utilization rates, we're looking at around 35% of the global power generation in 2025 from renewables. And when we look at the renewable capacity additions, it is solar that is the largest market, and we expect it to continue to be so. Here we're looking at annual capacity additions by energy source. We kind of zoom in on solar on the right-hand side. And 2025 will be a record year for renewable capacity growth with above 600 gigawatt in AC terms, combined for both solar and wind. And on the solar side, we're looking at near 500 gigawatt in DC terms, no, in AC terms, so nearly 600 gigawatt in DC terms to be added this year, mostly in Asia Pacific, but also record kind of additions are continuing in both EMEA and Americas. And in terms of sectoral breakdown, here is around 60% utility scale, and then 25% commercial and industrial, and around 15% the remaining for residential. And with this record and kind of gradual increasing both power demand and rapid renewables build out, we are seeing a massive need for grid upgrades, and we are ahead now of a major grid investment cycle here, illustrated by our estimated for a grid development in length on the left-hand side and investments on the right-hand side. So we're talking about annual grid investments on the scale of $500 to $600 billion per year till 2030 and going up from there. And there's 3 main drivers for this grid build-out. It's power demand and power supply, like we just looked at. And then there's also aging infrastructure, of course. And in particular, in US and Europe, we have very mature grids where a larger share of investments will go into refurbishment. And as a result, today's around 80 million kilometers of grid are set to expand to almost 160 million kilometers by 2050, so a near doubling. Transmission grid is making up around 6.5 million kilometers of this. Today is around 8% of the total length, but it has a higher share of on the investment side. And with this large build out in grid, basically across all regions, we are already seeing that TSOs and DSOs, such as in Europe, we are having TenneT, Amprion, RTE, National Grid. All of these are now committed to investment plans that are representing investments that are kind of on the scale from 2 times up to 10 times the amount of investments in the next kind of decade compared to what they did in the previous decade. So there is really a shift now in investments. And with grid being the primary and also largest end-use sector for power transformers, this is then, of course, leading now to a high growth in transformer demand. Here illustrated on the left-hand side by kind of annual spending, and on the right-hand side in the annual market size in power capacity for transformers above 10 MVA. So we're estimating an annual market size in dollar terms for 53 billion in 2025, corresponding to around 2,700 gigawatt amperes, or around 50,000 units globally for this MVA ranges. And we have seen a more dramatic growth. Kind of if we see both historically since 2020 and up to 2035, we're seeing a more aggressive growth on the monetary side. That's because of this also takes into account price increases, which has risen quite a lot. Whereas for capacity, we are seeing a more modest growth over the next 10 years of around 3.4% annually, which represent the actual number of accumulated capacity we expect to come online. And on the capacity side, just in terms of numbers, US makes up around 11% of this, and Europe makes around 14% of this market. So we are seeing that based on the grid build out, there will be a sustained long-term demand for transformers, and the supply chain will need to adapt basically in a synchronized manner to make sure we are able to balance supply and demand. And when it comes to supply, the way we assess this in Rystad is to essentially map out every single power transformer manufacturing plant. We have mapped out over 300 plants in more than 50 countries, so near 200 manufacturers globally. And for each of these plants, we are then researching kind of what are the capabilities in terms of minimum to maximum MVA they are producing. And based on the size of the plant in area from satellite imagery and also kind of company financials and any reporting, we're then estimating the demand for each of these plants. Because of course, for many manufacturing plants, it's not really publicly available what is the size of the plant. And we are seeing, we can look at the map to the right, that kind of, when it comes to the upcoming plants here in orange, there are new upcoming plants that are now being announced across all major regions in the globe. But if you are now combining all of these plant capacities across these 324 plants, we can see here on the right-hand side that kind of we estimate that Asia has nearly 60% of the global market when it comes to capacity, but they're also the largest share in demand. And this is then based on this plant-by-plant level estimate. So the OEM landscape might be a bit more fragmented than many people would think. But there is now an increasing number of companies that are trying to ramp up their capacity and export to new markets. But of course, many of these companies, particularly in China, are catering to domestic demand primarily. But we are now seeing that because of supply shortages in the Western countries, there are an increase in exports from China and other Asian countries. And looking a bit, one way of kind of analyzing the market is by looking at international trade flows. And here we're looking at international trade for Europe, Asia, and North America, with the exports on the top and imports on the bottom row. And Europe and Asia are really the largest regions when it comes to exports globally. Europe and Asia make up nearly 80% of global exports, and they're both then the two major net exporters. Europe mainly exports to other European countries and also to North America, so mainly the US, whereas we can see kind of the top middle graph that Asia is exporting basically to a wide variety of all regions globally. Whereas US, they don't, or North America don't export much. These North American exports are essentially mainly Mexico and Canada into the US, whereas they import quite a lot from both Europe and South America. But we can see here that on the bottom row for imports, that both for Europe and for North America, China is making up a quite sizable share of the imports. And if we look at how this has been trending in the last few years, there's an example for looking at the trade flows for Europe. We can see that there's been an increasing reliance of a non-European equipment. So the imports are here on the lower side of the x-axis, and we can see that actually in 2023, there was a doubling of non-European transformer imports into Europe. So this is highlighting both that kind of there is this undersupply in Europe. We are not able to cover basically the regional demand with the regional supply, and also highlighting that there is some excess capacity in Eastern countries. So historically, Europe has been a very self-supplied region when it comes to power transformers, but now their trade surplus is decreasing. And looking at kind of the top countries that has been importing transformers into the Europe over the last 4 years, we can see that there are here both China and South Korea are now kind of on the top list. China is the number 5 largest exporter. And also South Korea is growing market share when it comes to exports to Europe. And one example of this is Ukraine. In Ukraine, there was just reported that Ukraine has imported around 340 million worth of transformers in the years, from January to April. And almost 80% of those transformer imports to Ukraine this year has come from China. And that's because they are able to deliver basically lower lead times and prices than what the European and US and other Western manufacturers has been able to. So let's now look a bit into how we kind of ended up in this situation and how OEMs are responding to these market conditions. In terms of a short kind of story, we have seen that OEMs are not really prepared for this very large jump in demand that we have seen in the last 3 years or so. And the industry has previously been struggling basically over the last decade with overcapacity and low utilization rates. So now when demand picked up again, there was quite a hesitancy to invest because people were afraid of basically going back into overcapacity. And because of that, OEMs has invested a bit more reactively, so not really proactively. And they've been waiting for order books to fill up before actually committing to new capacity because they've been afraid of ending into lower margins and overcapacity again. But now demand has really picked up. And in the last couple of years, we have seen that OEMs are now have started to commit quite intense expansion plans. So most large players have now significant investments to expand capacity. Here's an overview of some upcoming plans. For example, Hitachi announced just around 1 year ago that they're investing around 1.5 billion, or actually over 1.5 billion by 2027 to increase capacity globally. And also Siemens Energy are investing around $1.3 billion by 2030 to their grid technology division. The largest share of these announcements are coming in the US. That's where we see the most projects. But since most of these announcements were made kind of within the last year, and it takes typically 2 to 4 years for the investments to materialize into production capacity, it means that a lot of the additional capacity is not really coming online until 2026, 2027, and onwards when these plants start to ramp up. So we don't see any immediate relief on the supply side, since demand is also continued to grow this year. But we are seeing new announcements. Just in the last weeks, we saw Vantran and MGM now opening a new facility in Texas for liquid fuel transformers. And also it was just announced that Product GE are now investing in a new facility in North Carolina in the US to aim to double their capacity by 2030. But if you now look, we look now a bit on the growth on demand, and with these expansions on supply, it's now interesting to see if this will balance out the market. And from kind of the estimates that we have done so far, with looking at kind of the global share of demand and supply on the left-hand side chart, we see that there is quite a balance between where the global supply and demand is located. Asia and Europe, as we saw, are the largest two exporting regions. They have a bit higher share of supply than demand. But looking at how the absolute numbers have trended over time, we see that since kind of a quite balanced market in 2019, 2020, demand has risen kind of on the scale of 20%, whereas supply that has been announced has only risen closer to around 5%, which has now led to this undersupply situation that we are in now. So it will be important to continue to kind of track these major plant investments and seeing how the market responds when these additions start to come online. Already some have started to come online, but we expect more to come online in 2026 and 2027. So it is for sure still a continued need for the supply chain and for manufacturers to continue with this strategic capacity planning to align with the increase in demand. And with this situation of undersupply, of course, one of the effects of this has been increase in prices, which is a consequence of several kind of price drivers, some listed here, kind of both on the demand side and on the supply side. And from around 2020 to last year, we have seen that average prices for internationally traded transformers have increased by around 40%. In Europe and US, the numbers are higher, close to around 50 to 60%, whereas in Asia, it's a bit lower, closer to 30%. And in terms of the status of kind of the price drivers going forward, we have seen that on the demand side, there's still quite strong drivers in terms of continued demand. On the production capacity and labor shortages for OEMs, there is now investments in place, but it will take some additional time before this really takes a large effect. But when it comes to raw materials and prices and availability, we have seen some relief from kind of the peak in 2022 and 2023. So for example, some of the main important input materials for transformers with cold rolled and hot rolled steel, and of course grain-oriented steel, mineral oil, these commodities have seen now a bit of reduction in prices, but we haven't really seen this translate into a large reduction in prices for transformers yet. So we still see elevated prices. And the effect of this is that, or one effect is that OEMs have now been able to increase their margins. Here's an overview for a selection of kind of the publicly listed transformer manufacturers that are either kind of pure play transformer manufacturers or have a significant share within transformer manufacturing. And while many OEMs saw kind of a dip right after COVID in 1920, we're now seeing that just averaging the margins for these companies in the black dotted line, we have seen that the average of these have increased from kind of around 8 to 10% mark, and now averaging up to 13% in 2023. And for the latest number, around 17%, with, for example, Končar in Croatia, seeing margins up to 30% and higher in the last quarters. So they have been able to increase their margin as a base of this. And another effect that we are, of course, most people familiar with is there has been an increase in lead times, kind of on the scale from months to years. With the average lead times for power transformers has more than doubled now since 2019. And just what I heard last week, kind of the longest lead times that people are still now getting quoted is on the scale of actually 7 to 8 years from you bid till you get delivery in some cases here in Europe on the extreme side. And of course, these numbers here, there are huge variations within all of the product categories. So it's more, the interesting thing here is to see the increase or kind of the trend rather than the absolute numbers. But we are hearing that Chinese suppliers are reporting lead times for kind of the high voltage transformers of 6 to 12 months, and for smaller transformers down kind of to 2 to 4 months scale, which is much lower than what we are seeing in Europe. But here in Europe and US and in most places, the market is still very tight, and there will continue to be a quite challenging procurement environment. And historically, for many buyers, it's been sufficient to basically just pick up your phone and call some of your trusted contacts or handful of suppliers that you have been dealing with to get a reasonable price and lead time. But now there is a need for a bit more strategic procurement, which is also why we in Rystad are now tracking this quite detailed to help support some of our clients on this. And I'm not, as always, there's not any one silver bullet to deal with this, and I didn't want to rank any specific risks or mitigation factors because it's very dependent on the exact company and sectors, but I've included some comments. And on the risk side, as we discussed, there are risks related to OEM supply, to international trade barriers, policies, and kind of how fast demand will grow. And as a buyer, I've categorized into kind of 3 main segments that you can influence in terms of mitigating sourcing risk. And that is enhancing the confidence for the suppliers you're buying from in terms of being more transparent in long-term planning, and also joining forces with other buyers where possible. And hedging yourself in terms of diversifying your supplier base, using these type of supplier databases to see other potential buyers that your peers are buying from, and also extending planning horizons. Then, of course, making yourself as a company as attractive as possible to work with in terms of simplifying and making processes more efficient. So you're an easier company basically to approach. And then to conclude, we are, as you have seen, kind of in this market situation where transformers and also other types of grid equipment are seeing rising demand, and we are expecting this demand kind of to increase with the basis kind of macro when it comes to power demand and supplies we looked at in the beginning of the presentation. And shortage of labor and kind of these reactive investments are continuing to be remaining challenges. So it is important for all companies to strategically plan to make sure you're taking this into account. So you cannot really longer just pick up your phone and call the company and be sure that you get the lead time and price that is what you need. So there is now an increase for sure for this strategic data-driven procurement, for example, by leveraging these trade databases and manufacturing databases to understand who your peers might be buying from, and also using these price indexes to make sure you're essentially buying the market price and not contributing to increasing margins, when we have seen that some of the underlying price input materials actually have reduced in their pricing. Yeah, that's all I had prepared. So thanks. Now let's move on to Arthur's section of the presentation.
Thanks a lot, Edward. It was really interesting. I'm always amazed by your company's nice graph and how you managed to get those. Yeah, good morning, good afternoon, good evening, everyone. I am Arthur Claire. I'm the director of technology at Sinovoltaics, and now we are going to continue to talk about transformers. Maybe simply just 1 minute about what we do at our company, Sinovoltaics. We help our clients to reduce their supply chain risk. By supply chain risk, we mean quality and traceability and ESG. We focus on solar modules, inverters, transformers, and energy storage system. by quality, by reducing the quality risk for transformers, we can either perform technical factory audits or the monitoring of the production. Given the really long lead times that we are seeing today, we can go to the factories at certain milestone and evaluate the progress of the manufacturing of the transformers. We can also be there for the FAT, for the factory acceptance testing, to make sure everything goes as per the FAT checklist that we are going to discuss. And last but not least, we can also be there for the loading of the transformer into the container and making sure everything is going well before the shipment from the factory. On the traceability and ESG side, it's more new, I would say, for transformers, but we can still provide ESG audit directly at the transformer factory or supply chain mapping for your entire transformer supply chain. And also, I see there is one question about the UFLPA. We can also provide traceability evidence that can be used to import transformers into the US or anywhere in the world. Okay, so let's start with supplier selection of transformers. One point you need to be extremely careful about is that, of course, different suppliers, all manufacturers are not equal. You need to be careful about the supplier you want to use. But also within one supplier, they may use different factories that will have different quality level, for example. And even within one factory, they may have different production lines, different workshop that will, of course, influence the quality of your products, of your transformers. And of course, the quality can usually change depending on the experience of the staff, of the manufacturing equipment being used at the factory. And also you need to be careful about the outsourcing of the manufacturing of the transformers. It's actually a key point we are seeing more and more at the moment. And actually it's a question I want to ask to our audience, kind of action for you to take away from this webinar, is do you know where is your transformer manufactured? Because we see, as I mentioned, more and more cases where the client was buying, for example, a medium voltage station, but actually from supplier A, let's say, actually supplier A was buying all the transformers that will be put into the medium voltage station from another company. And of course, the client was not aware of it. It's something that we have found out as part of the audits. And so, yeah, it's one point I will strongly advise you to check as part of your next projects. And about this, one solution is to provide factory audits, is to perform factory audits. So at Sinovoltaics, we can perform quality, supply chain mapping, as well as ESG audits. Ideally, you have, I would say, two main milestones where you want to run it. First one is when you have a short list of suppliers for your transformer station. Of course, then you can use those audits to compare and to evaluate each shortlisted candidates. So second milestone is, I would say, a couple of weeks before the start of the manufacturing. You want to run a quality audit at that time so that we can basically come up with a list of non-compliances that may influence the quality output of your order. And we will work with your supplier to solve those non-conformities and making sure you get the highest quality at the start of the production. Okay, now let's move to transformer contract. So as a forward, I would say be extremely careful. What is not in the contract is not covered. So your transformer salesperson might be extremely nice to work with, but if it's not in the contract, it's not going to be nice again if you have any issue 3 years down the line. So be extremely careful about it. And so what kind of topics you want to have in your transformer procurement contract? First of all, is to have the specification of your transformers, especially since for some projects you have a custom-made product. So it's really important that the specifications of your transformer is part of the contract. Second, it's really important that you put the inspection and audit rights so that you can either decide internally to visit your supplier or to hire a third-party inspection company like us to go to the factory to perform factory audits or to be there for the monitoring of the production or as part of the FAT. And also talking about the FAT, what is important is to ask for the checklist of the factory acceptance testing, so the last test before shipment, FAT, and to basically check what is included in there. We can also help you to negotiate tighter FAT checklists with your supplier, but it's really important that you include this at the time of the contractualization, because if not, we have seen many cases where the client asks for it because they have hired us a couple of weeks before the FAT, and they realize at that time that the FAT checklist is only composed of a couple of tests, and they get super disappointed at that time. And of course, it's really important to include this as part of the contract. Tightly linked to this, there are some data generated during the FAT, during the factory acceptance testing for transformers. We strongly suggest that you that the supplier share those data with you, and so that you put this in the contract. Also, as we have seen, the timeline for transformers is extremely long, can be over a year or even two in some cases that we have seen recently. And we strongly advise to include some penalties in case of any delays related to specific milestones that you will have written in the contract. And last but not least, we see this more and more. If you have traceability requirements in terms of CO2 emissions or in terms of ESG, you need to include this as part of the contract. This topic is still really new for transformer suppliers, so I would expect them to be usually afraid of such requests. So if you don't include it when you have the most leverage, so before the contract signature, then you will have less chance to have it approved. Okay, so now let's move to the FAT. What kind of tests do we perform during I would say a typical transformer FAT checklist? First tests are all about visual inspection. So here the goal is to ensure that the mechanical specifications, for suppose that the dimensions are matching the specifications. Here, what I found, you can see it on the left side, what I found quite funny always on the pictures, that since transformers are usually quite big, our inspectors need to find the best positions to take the measurements. And here on the right, you have a picture of the coating fitness check, which is extremely critical, because of course you want the coating fitness to be uniform all around the transformer, which is not always the case. And so, of course, we'll use such equipment to evaluate the coating fitness, and we will do this at multiple points around the transformer. Okay, next we have a lot of voltage ratio. So as you know, the purpose of transformer is to either go one level up or one level down in terms of voltage. So here you will have, of course, it's quite important to connect the test wires, and we will basically check all the different gear or the different voltage ratio of the transformers to make sure that the voltage ratio is as expected between the primary winding and the secondary windings. Next, so of course, we'll also evaluate the winding resistance. And here, so of course, between the primary and the secondary windings. Here, the purpose of this is to evaluate if there is any manufacturing issue. So for example, some loose connection or some poor soldering in the windings. So you need to make sure, of course, you need to create some wire. Here, you will send some DC current to evaluate the DC resistance of the transformers. Okay, next we also focus a lot on the insulation oil test. So oil is being used as the insulation liquid, insulation body for transformers. So here what you want to check is to evaluate the quality of the oil. Is it going to be good for your cases. So we do several tests there. We first of all check the dielectric strength and the dielectric loss of the fluid, of the oil, just to make sure that it's going to sustain a high enough voltage in case there is an issue. We also check if there is any water content that could be in the oils, that actually you could see more and more water being generated as part of the degradation of the oil. So you want to make sure that, for suppose there's less than 1 milligram of water per kilogram of oil. That's the kind of range we are looking at. And last but not least, you need to look at the gas composition of the oil. And here we'll be extremely careful about the hydrocarbon composition. So if you think about the CH4, for example, or C2H2, we will really evaluate the different gas being part of the insulation oil. And what you need to be extremely careful about is about C2H2, for example, because this gas is only generated when there is arcing as part of where some arcs got created in the transformer. So when you have such presence of this gas in the insulation oil, usually it will be a fail for the FAT, and we see this sometimes. Okay, then we have temperature rise test. So kind of related to the insulation oils, as oil is used as the heating dissipation fluid. Here, you'll need to make sure that the temperature stay under the normal conditions when the transformer is working normally. So here, directly at the factory, we'll connect the transformer and we'll run this test, and we'll check the temperature of the oil at different part of the containers. So for example, at the top oil, which is used when there is too much heat generated, of course, the liquid will extend. So you will have a certain reservoir for this. And also we check the temperature of the radiator at the bottom to check what is the temperature difference and if it's always within specifications. Next, and it's highly critical for some countries where they have really strong sound level specifications. I'm thinking about Germany, for example. So here, they're really evaluating the noise being generated by the transformer under normal operating conditions. So here, I'm not sure if you can really see it. On the left, you have the inspector with this yellow stick who is taking the measurement of the sound. And on the right, you have the value of this test. There are also other tests that are performed as part of the transformer factory acceptance testing, FAT. I listed some of them here, but as you can see, it's really critical that you have a clear view on this FAT checklist as part of your contract negotiation for the transformer. I believe it's also a really strong way to compare suppliers as part of the selection process. So I would strongly advise you to contact us if you need any support for this, and to at least ask your supplier for the FAT. Yeah, last but not least, a couple of months ago, we released this mainland China transformers factories map, where, as the name suggests, we mapped all the transformers factories in mainland China. It doesn't need to be related to Chinese brand. We could see here on the map that, for example, ABB factories are on there. So it's not only related to Chinese brands, but I think it's a really interesting map that we created there, especially if you had trouble with specific lead times. We have tried to list the factory contact information as well. So we really believe it could be a useful tool for your supplier selection, for example. Okay, and that's it for me. So yeah, we are, as Reza mentioned at first, I'm located in Switzerland, but we have people in Asia, of course, Europe, and also in the US. Please feel free to reach out to us in case you have any questions.
Thank you, Arthur, and thank you, Edward. Both very insightful presentations. So I understand that the undersupply is here to stay for some time, and so are challenging procurement conditions. And strategic data-driven procurement could be an effective solution to the power transformer shortage and long lead times. What we also learned today is that what is not in your power transformer purchase contract is not covered in the event of non-conformity. And last but not least, what just Arthur explained, we got practical insights on how a proper factory acceptance testing is done and why it's important when purchasing power transformers. So I now want to cover the questions. Thank you very much to our audience for raising these questions. So Christopher would like to know, why is the timeline for procuring transformers so long? I guess, Edward, that's a question for you.
Yes. So thanks for the question. So to clarify, there are, since essentially the last 2-3 years, we've seen that renewable generation has started to really pick up in terms of the installed capacities that we are seeing. This was expected, but actually transformer manufacturers were not really prepared. They didn't expect this large demand growth. So it was the case that most OEMs didn't really realize how much extra need there would be for transformers with this kind of catch-up effect of both there being an increased demand from kind of new generation capacity that is being built out, in addition to modernization and replacement of existing old grid. And one of the reasons why OEMs were quite hesitant to increase capacity is, as I mentioned, that there has actually been a quite bad market for transformer OEMs, or a challenging market in the last 10 to 15 years, where there has been periods of kind of under utilization and oversupply, meaning that most manufacturers would rather wait to see kind of the order books fill up and margins start to increase before they want to do any very capital intensive expansions. So it's a bit of a reactive and hesitant response to the increase in demand, which is basically the case that demand has increased a lot, but it took a quite long time for supply to catch up. And it is a very transformer manufacturing is a very manual labor. It's not something that we have been able to automate. So when it comes to, for example, doing this winding for large power transformers and doing the insulation, there is a lot of manual effort needed, and manufacturers have not been able to then scale up very quickly to match with the increase in demand, which is why we are now seeing these very long timelines for procurement, until hopefully it will start to go down once many of these committed expansions are coming online in 2026, 2027 and onwards.
Thank you, Edward. Another question from the audience is from Lance. Does UFLPA guidance apply to transformers for imports into the United States? I think, Arthur, you slightly touched on this question. Do you want to elaborate?
Yeah, of course. So first of all, the UFLPA apply to kind of any component being imported to the US. That it states that you cannot import products that got manufactured or that are using raw materials from the Xinjiang region in China. So transformers apply to this just like any other products being imported to the US. I guess this question is coming because in PV modules, for example, you have really strict guidelines to follow to import PV modules into the US. There is no such guidelines for transformers, but if you have any doubt, or maybe your investors or your lenders may ask for evidence that there is nothing tied to Xinjiang, I would suggest to perform a supply chain mapping audit.
Thank you, Arthur. Another question from the audience we have, again to Arthur. Why do we use oil in transformer?
Yeah, so oil is used for two main purposes. First one is for electrical insulation, and second one is for the heat dissipation. So because you need a fluid that works well with both, of course, you cannot use water, which is okay for cooling, but for insulation is really bad, as you can imagine, while the insulation of oil compared to air is much better. So that's why oil is, I would say, standard for cooling for transformers.
Thank you, Arthur. Question from Christopher to Edward, I guess. What trends are you seeing in supplier consolidation or geographic shifts in transformer manufacturing?
Yeah, interesting question. So we have seen in terms of geographic switch that more and more, or the area with the most rapid demand in growth right now is kind of shifted a bit to the US, especially with data center growth and also more solar installations. We are seeing that there are more plant expansions now happening in the US, because historically US has been very reliant on imports, and they are still very reliant on imports. So for large power transformers, I think it's around basically 20% of the market is from domestic manufacturing and 80% is imported. So now there is a home shoring kind of initiative and more investments going into expanding capacity in the US. But there are also basically expansions in all other regions. We are seeing a lot of expansion in Asia, but then the amount of expansions compared to the already installed capacity is not that high. So US is basically the regions where we see the most amount of increase in relative supply capacity. And when it comes to consolidation, we haven't seen a lot of consolidation, as I'm aware of yet, but it could of course happen. But we are basically not seeing a large uptick in M&A for large OEMs.
Thank you, Edward. We still have time, and more questions are popping in. Another question is again for you. So what are the most common procurement challenges in transformer acquisition, and how can they be mitigated?
Yeah, thanks for the question, Alex. So I think the main challenges, if you are procuring from Western companies, will be that if you are a smaller buyer, it's very hard to get prioritized by the OEM, because they can basically now cherry pick which buyers they want to work with. And typically they will choose large TSOs that are able to commit to long-term kind of buying agreements, because they have commitments in terms of how much they're going to invest into their grid. So if you're developing kind of one solar project, for example, it can be hard to get prioritized if you're not buying in quantity. And to kind of mitigate this, it's important to try to understand which suppliers that are available in your region and not only rely on the largest ones. You probably will get a better chance from a bit of the smaller manufacturers, since now many of the larger manufacturers are already now trying to get very good agreements in with large buyers. And then if you are acquiring from kind of new regions, for example, from China, then I guess one of the main challenges will be to actually ensure that this supplier has a good track record and will be able to deliver kind of both on the equipment, but also on the maintenance and kind of follow-ups that you need. And then I guess there is a need for this type of supply chain audit and due diligence, which is required.
Thank you, Edward. Two more questions are about the ESG. So I guess, Arthur, these are for you. Traceability and ESG are becoming hot topics. How can buyers realistically build those into their procurement process without getting too overwhelmed? A question from Lance.
Yeah, and there is also this question from Rystad. Who do traceability requirements typically come from, and what is their main purpose? I think both questions are kind of connected, so I will answer to both. First of all, the requirements, I will start there. So requirements are coming either from the lenders for the PV, BESS, wind projects. We see this especially coming in the EU, and in the EU specifically from the Nordics. So they will ask you to provide evidence that there is no forced labor, for example, and from those requirements, you will need to provide evidence, as I mentioned, supply chain mapping audits, for example. And so you will need to translate those requirements into the procurement process. Because if it's critical that you provide such report to your lenders, but the supplier refuses to have any audit team at the factory, of course, you cannot use that supplier. So it needs to be part of your procurement process. Then, of course, as Lens mentioned, it's still new for transformer suppliers. So I will start with something kind of small and short and say, okay, we want to do supply chain mapping audits. We want to do ESG audits, and let's see how they react about this, what kind of maybe of traceability documents they already have available for you. And you can use this just like for any quality topic. You can use this as part of the evaluation process for suppliers. And yeah, I think today that's the way to move forward.
Thank you, Arthur. And one additional question from Lance, I guess to you, Edward. In the next year or two, do you expect transformer prices to rise, fall, or stabilize?
Yeah, thanks for the question, Lance. Of course, prices are notoriously difficult to predict, but I would say that based on what we have seen in terms of announcements from OEMs and the amount of capacity that is getting online, I think it will continue to stay elevated throughout this year, since there is not very large new capacity coming online. And then there can be some relief in 2026, 2027, when these new major investments, for example, from Hitachi, Siemens, and others, are starting to materialize into kind of ramped up production. But still, I think prices are not going to come down to like 2019, 2020 levels anytime soon. So it will stay elevated, but I see that there is some downside or kind of potential for reduction in 2026, 2027 when new plants come online.
Thank you, Edward. We still have a couple of minutes left, so we'll take a couple of questions. I guess a question to you, Arthur, is it recommended to ask for FAT reports to supplier for all transformers?
So short answer is yes. You need to differentiate where you are in the procurement stage. Before conceptualization, I will ask for the FAT checklist so that you can compare different suppliers, the kind of tests they do. And after, for your own FAT, for your own transformers, for your own projects, I will definitely ask for the FAT reports for each of your transformers.
Thank you, Arthur. And one last question from David is, how important is the selection of the OLTC manufacturer in a high voltage transformer? I guess a question to you, Arthur.
Yeah, again, short answer, yes, it is important. It's a component that is highly under stress as part of the life of the transformer. And yeah, I will ask for kind of the BOM potentially of the transformer to check what kind of OLTC is included there. And also we'll be careful about the OLTC suppliers and see if there is any spare parts that could be provided as part of the project.
Thank you, Arthur. Thank you, everybody who raised the questions and for being engaged in this webinar. Those questions that we were not able to answer because of the time constraints, we will follow up via email. I once again want to thank you both Edvard Christoffersen and Arthur Clare for this insightful session. Here are the contact details of both of our speakers. If you need some guidance on how to navigate this challenging world of transformer procurement. So thank you, and see you in the next Sinovoltaics webinars.
Thank you. Bye.
Thank you very much. Have a good day.
Thank you. Bye.
Visit Sinovoltaics.com and rystadenergy.com to learn more.